video, we're going to look at the first 4 multiple choice problems on the Chapter 4 practice test. So let's start with problem 1. When we take a census, we attempt to collect data from either a stratified random sample, every individual chosen in a simple random sample, every individual in the population, a voluntary response, or convenience. So really this is asking us to define what is a census and apply that definition. Well, a census is a study that is trying to collect data from every single person in a population. Think of the census when we do it for the country, is we're trying to get information on every single person. We're not trying to just create a random sample of people. We want everyone accounted for. So that's a basic definition for it. But even though this is about census, that means we have to understand what's the definition of stratified random or simple random or voluntary response or convenience on it. So even though this problem is asking us just to define census, we should also be able to identify each one of these as well. So let's look at number 2. This one's asking us to apply a table of random digits. We want to take a simple random sample of 50 of the 816 students who live in dormitory on campus. So we label the students 001 to 816 in alphabetical order. And the table of random digits we're going to use is shown. So we're asked to find the first 3 students in this sample. So let's first identify a couple things on it. If I'm trying to look at this, we're trying to do a simple random sample of 50 students from 816 students who live on campus. So this right here, 816 students who live in the dormitories on campus, that is defining our population that we're trying to study. Our sample is 50 of those selected at random. Also pay attention to how it is asking you to label. I mean, the way the problem is asking us to label students 001 to 816 in alphabetical order. That's how you would state it if this were for the response problem. So it looks like we are dealing with, if we do the problem now, 3 digits. So when I'm doing this, I'm going to break this table of random digits into groups of 3. So the first number I get is 955. Well, I want from 001 to 816, so that is not in my list. 929, that is not on my list. 400, that is in the range we're looking for, which means I know the answer either has to be B or E. Well, if we look at the difference, the next numbers are both 769. So let's see. If I look at the next 3, it is 769. So that doesn't distinguish. It's still B or E. But the next grouping is 769 again. So we have to ask ourselves, the difference between these is, do I go on, keep 769? Should we ignore repeats? Because 769 appears again, but notice the next number, the next 3-digit number is 335. So it's got to be either this one or it has to be either this one. We know based off of asking the question, should we ignore repeats? In this scenario, we are trying to do a simple random sample of 50 of the students who live in the dormitory. So are we going to interview the same person again? Are we going to include the same person in that sample? And the answer is no, we're not going to. We want 50 unique students from that 816. We're not going to ask the same person to either the survey again or interview them again because we already have their information gathered. So in this case, should we ignore repeats? Yes, which means the answer is not B. The answer is E. Number 3, study of treatments for angina, pain due to low blood pressure to the heart, compared bypass surgery, angioplasty, and the use of drugs. The study looked at the medical records of thousands of angina patients whose doctors had chosen one of these treatments. It found that the average survival time of patients given drugs was the highest. What do you conclude? So we really have to understand this prompt before we start reading these choices. So if I'm looking at this, there was a study, okay? It's comparing three things: bypass surgery, angioplasty, and the use of drugs. How was this study conducted? It looks like the study was conducted by just looking over medical records. So I think that's important to understand is this study, the person just grabbed medical records from thousands of patients and just looked to see what the doctors have chosen on it. So let's try and read these choices and see what we can do. This study proves that drugs prolong life and should be the treatment of choice. It did say it found the average survival time patients given drugs was the highest. We can conclude that drugs prolong life because the study was a comparative experiment. Well, a comparative experiment. Was this an experiment? I mean, we were comparing records. But did we set up an experiment? So if I take a look at this, was there an experiment? And no. This person just looked at the records. There was no, wait a minute, wait for it. There was no randomization. So there was no randomization done. The person just grabbed thousands of records and looked at them. So that's actually, maybe that's crucial to know. There was no randomization on it. So it's not an experiment. If we go through, we can't conclude that drugs prolong life because the patients were volunteers. Well, no one volunteered. The person just looked at the records for it. We can't conclude that drugs prolong life because this was an observational study. I like that one. We're still on hold on A. I haven't gone back to that one yet, but I like it because it was not an experiment. The person just observed the records. They looked at them. We can't conclude that drugs prolong life because no placebo was used. Again, this was not an experiment on it. So we can't do that. So let's take a look. It's either A, the study proves that drugs prolong life and should be the treatment of choice, or it's D, we can't conclude that drugs prolong life because it was an observational study. Now that's interesting because those are complete opposites. So if we know it was an observational study, the question we have to ask ourselves is, can we conclude cause and effect from an observational study? And we can't. We know for sure it was an observational study. And can we conclude cause and effect? No. The only thing that can conclude cause and effect is well-designed experiments, which means the answer is D. We knew it was an observational study because he looked at the records on it. Let's look at number 4. A simple random sample, again, looks like it's a definition. Simple random sample is any sample selected by using chance, any sample that gives every individual the same chance to be selected, a sample that gives every possible sample of the same size the same chance to be selected, a sample that doesn't involve strata or clusters, or a sample that is guaranteed to be representative of the population. So this is the last problem in this video. I'm going to slide up the top for a minute because I think it's important we understand the directions. Select the best answer. So I want to know which of these is the best. A simple random sample. Any sample selected by using chance. Well, I like the fact that this uses the word by chance because that's what we want. But there's something wrong. There's a word missing. It's okay the way it's worded, but we're missing. We need equal chance. It's not just by chance. Every object in that sample has to have the equal chance, the equal probability of being selected. So I don't like this one. I'm missing the word equal. So that's not the best answer. Any sample that gives every individual the same chance to be selected. Well, what was missing in A, I can see in B, so I like that so far. But is it the best? I don't know. A sample that gives every possible sample the same size, the same chance to be selected. Well, if I compare that to B, they're very similar. What's the difference between B and C is this one addresses that sample size plays a role in it. Every possible sample of the same size has the same chance to be selected. That's really the only difference between B and C. So I'm going to keep both those for right now. A sample that does not involve strata or clusters, and that's, a simple random sample by itself does not involve strata clusters. But remember, when you do a stratified random sample, you do a simple random sample in each strata. But it's not the best, it's not the best way to answer that question. There's better ones. B and C are way better than D. A sample that is guaranteed to be representative of the population, it's not guaranteed. We do randomization for it. There's still variability. We're trying to reduce variability. We're trying to reduce bias with a simple random sample. It doesn't guarantee. We are trying to reduce bias and variability. So the answer is either B or C. When you're doing a simple random sample, one of the things you have to realize is you do have to define a sample size. And we want to make sure when we take a sample size that every sample that is taken of that same size has an equal chance of being selected. C is it is the best definition of a simple random sample. So these are the first 4 problems for the multiple choice. We have C, E, D, C for them. Hopefully this helps you understand the importance of definitions from number 1 and number 4, and some of the things of when do we ignore repeats and the idea of cause and effect or observational studies versus experiments.